we describe how to build a Unity scene to collect the experts demonstration data. So this Unity program works like this. When you hit play, okay, and you use up, down, left, right arrow keys to drive the car to reach the goal and avoid the obstacle, avoid hitting the obstacle. Okay, so first and second demonstration. Let's do third demonstration. Well, I am kind of slow in playing this. If you have been playing game, then you will perform much better than me. Okay, it works like this. So now I perform 3 demonstrations. Now if I hit stop, my data will be recorded here in a file called record. So here, trajectory 1, trajectory 2, and trajectory 3, 4. Okay, so here I collect 4 trajectories. Each trajectory is delta x, delta z, and 5 distance sensors, and then the speed and rotation, and S prime. Okay, so let's quickly review. In this semester, we already do a lot of projects for reinforcement learning, where we use Unity to build the simulation environment and use the ML agent to build the agent and interact with PyTorch to train the neural network. And it works like this. Okay, so the PyTorch, the neural network implemented in PyTorch, interact with the Unity environment through ML agent to learn. Okay, here's some results. Okay, the reinforcement learning is useful when we can define the reward, and we have a simulator to let the agent learn something based on the reward function. But in many real-world applications, like self-driving car or self-driving helicopter or self-driving drone, it's very difficult or even impossible to define the reward, or the reward may be very brittle. Okay, for example, if the car wants to drive in a cliff, if your reward is not designed properly, the car may fall. Okay, so in many of these real world, like self-driving car, robot situations, we need to use imitation learning. We use expert to demo some trajectories. We use to demo trajectories for us, and then use these trajectories to train our neural network to learn. Okay, I will talk about the imitation learning algorithm in our next class meeting. So here I just show you how to use Unity to build a simple data recorder to record the expert trajectories. Here should S prime. Okay. SA, S2, and S2, A2, S3, blah blah blah. By the way, the slides here is taken from Stanford CS234 course. It's a very good reinforcement learning course. Of course, the Berkeley's reinforcement learning course are also very, very good. I really encourage you to take a look at the reinforcement learning course from Berkeley and Stanford. Okay, let's go to explain this. Okay, first is the scene design. Is the training world. Here's the plane. Okay, all these are the same as the training word we we developed for homework 4 and 5. Okay, here's the agent. Inside this agent, I install 5 sensors. Okay, with different rotation angles along z, minus 60, minus 30. Okay, in your word, if you want to place more sensors, simply copy paste. And here's the goal and the obstacle and the wall. I played for wall. Okay, and then I play UI text to display the current angle and degree. Okay, so in the mobile, in this agent, I place a rigid body. Okay, for collision detection. Okay, you need a rigid body on the object we assign the script in order to do collision detection. All these others objects we don't need to rigid body. Okay, but we do need rigid body on the object where we assign the script. Okay, and finally is the script. Here, because we do not use ML agent, so we do not use behavior parameters nor the agent script. We simply write a script which is simply mono behavior, not the agent. Also, we do not use ML agent because here is only a simple scene for data recorder. Okay, so I use Unity Engine.ui because here I place a GUI text. That's why in the script I have to use in Unity Engine UI. Also, I use System I/O because I need to write the data to a file. Okay, and then remember the class name must be exactly the same as the script. And then it's just mono behavior because we do not use ML agent in this case. And here these public variables. The first we have 5 public variables to tell this script where is the sensors. So if you go to here, you can see we have 5 transforms where we need to assign sensor 1, 2, 3, 4, 5 to this. Okay, and this raycast heat just used to remember the distance hit by the ray. And this goal obstacle we need to assign this goal obstacle. Also, okay, this ray length and the next record just used to record what is the next time to write a data. And this streamer writer is used to write to text file. And this public text UI text is used to display the current speed and angle. Remember to assign this GUI text to this public variable. And then the start function is run every time when we hit play. Okay, then we knew a stream writer, and we write data to a data file called record text under the assets folder. So under the assets folder, we will have a text file called record text. This false means we will overwrite. Okay, so every time we run, we overwrite. So remember to copy. If you want to copy this data, right click in the project window, say show in Explorer, and you can see this record. Let me see. This record data, and then copy it. Okay, otherwise next time, every time when we write, we will overwrite. Okay, and trajectory index just used to recall how many trajectories, and then we reset scene. Reset scene is similar to homework 4. We just reset the position of the agent, randomly reset the goal. Also, here are something new. We add speed and angle and then we write a new line and trajectory 1, 2, 3 to the, okay, that's why you see that's why you see here we have trajectory 1, trajectory 2, blah blah. Okay, and then the update function is run every frame. So every display frame we will run this update, but we want to record the data at a fixed time interval. So we just check if the current time is larger than the next record time, then we just set the next record time is current time plus 0.1. So means we record a line of data. We record a line of data every 0.1 seconds. If you change this, for example, if you change to 0.5, then that means we record a transaction every 0.5. Okay. And delta x, delta z, and distance to go we already explained. These three lines are used to display the debug array. Okay. And here we call a function to collect the current state. So we collect the as current state. Okay. The current state is delta x, delta z, plus the distance of these 5 sensors. Okay, so the current state delta x, delta z, and the 5 distance detected by the range sensors. Okay, and then we detect whether the key pressed by the user. Here we use up, down, left, right arrow key to do. If the user press up, then we will increase the speed. Down, decrease the speed. Left, turn left. Right, turn left. If the user hit any other key or do not hit any key, then we just set speed to 0 to let the agent stop. And then we perform the transfer, translate and rotate, and display the current speed and angle in this GUI text. And then we collect the next state. So here the S, and here the speed and angle, and then we collect the S prime, the next state. Okay, and then write to our text. Okay, and when the program finish, we close this text file. Okay, so that's how to build this, and how to use this data recorder to collect expert demonstration data for imitation learning. We will cover the imitation learning in our next class meeting.